everyone, this is the Physics 110 GR archive for GR2D. In this video, this will be the last one going over the true or false and short answer section. So in question 1, we have two cadets that are stepping off the 10 meter. One has a mass of 50 and the other has a mass of 75. It's saying that because the 75 kilogram cadet is or has more gravitational potential energy, he will be moving faster than the 50 kilogram cadet. So if we look at this problem, it's saying the 75 kilogram cadet has more gravitational potential energy. This is true because if I like to look at these true or false questions from a mathematical perspective before I explain it conceptually. But when we're looking at gravitational potential energy, we have U equals mgh. So yes, the 75 kilogram cadet has a higher mass, so he will have more gravitational potential energy than the 50 kilogram cadet. What we have to check, though, is the speed when they both hit the water, because that might not change based off of their weight. So if we look, we have gravitational plus kinetic initial is U final plus K final. What you can write this as is mgh plus 1/2 mv squared equals mgh plus 1/2 mv squared. We can simplify this a little bit. We know both of them are starting from rest and they're stepping off the 10 meter, so they don't have initial kinetic energy. And when they hit the water, they don't have any gravitational potential energy, because we're going to say that hitting the water is ground zero, and we're going to make that our zero. So looking at this, we're left with mgh equals 1/2 mv squared. Now when we get to this point, we can look and see that both of these terms have a mass in it. And so if we were to plug in numbers and everything and divide by that, mass would cancel out in both of these equations. So what that tells us is that it doesn't matter, since it's conservation of energy, it doesn't matter what their mass is, because it's going to be the same thing in the kinetic energy, and it's going to cancel out. So mass doesn't matter. All that matters is if the initial height changes, but they're both jumping off the same height platform of 10 meters. And so if h is constant, their velocity will be the same at the bottom because mass isn't affecting it. So this question is false. And I believe the person who did this GR said that, but I don't think they showed any math to prove that, but this is how you would prove it mathematically. You would just show that mass doesn't play a factor in this conservation of energy problem. Okay, looking at question 2, we have an archer that shoots two identical arrows, each with launch speed v. Arrow 1 is fired horizontally and arrow 2 is fired vertically. And then it's stating that the kinetic energy of the second arrow will be greater than the kinetic energy of the arrow 1 at the moment of release. So this question, or this answer, I'm going to just say it's false, and then I'll explain why. Because it's given to us that the launch speed of both arrows is v. They're identical arrows, they both have launch speed v, so that means when he releases the arrow number 1 horizontally, it's leaving with a kinetic energy of 1/2 mv squared. Arrow 2 is released vertically. It also has a kinetic energy of 1/2 mv squared. We know that both of these arrows have the same mass because they're identical, and they have the same velocity because it told us that they each have a launch speed v. It's trying to trick you by saying they're launched in different directions, but no matter the direction, the kinetic energy is still just 1/2 mv squared. And so if the launch speeds are the same, the kinetic energies will be the same. What would change this is if the masses were different, or if they told us something changed between the velocities of the two of them, then kinetic energy would change. But since mass and velocity are constant, kinetic energy doesn't change, and therefore the answer is false. So that's the end of this GR archive and this true or false section.